Hello everyone, welcome to my youth programming club. Today we will be solving another daily Leetcode problem, and the problem's name is remove zero sum consecutive nodes from linked list. So let me describe this problem statement in my own words. So what you will be given is you will be given a singly linked list. Okay, so let's say the linked list given to you is this particular one, and let me write it in the form of that you can visualize it how everything is going on. So 2 is connected to 2, then this 2 is connected to another -2, and then this one is connected to 1, then this one is connected to -1, and this one is connected to another -1 that is there. Okay, so what you have to do is you have to pick the consecutive parts in this particular linked list which are adding up to 0 and remove them. Okay, so if you observe that these, what will be these parts? Okay, these parts will be these 2 and -2 are summing up to 0. Okay, so if you do something like this, so it will add up to 0, and this one also is summing up to 0. So 1 plus -1 will be 0. So you have to remove this much portion. Okay, and join the rest. So your return the linked list that you will be returning is 2 and -1. Okay, so this is what you have to do in this particular problem. Okay, and let's have a look at the constraints also before talking about our approach of solving it. So the number of nodes between given linked list is between 1 to 1000, and each node in the linked list is having values between -1000 and 1000. Okay, so now the question arises how we are gonna solve it. So first of all, before discussing our approach, I would like to introduce our topic for those of you who are not familiar with it. Prefix sum. Okay, so let's take the previous example. 2 2 -2 1 -1 -1. Okay, so 2 2 -2 1 -1 -1. Okay, so this is the linked list that is given to you, and if you have a variable, let's call this prefix sum and initialize it to 0, and you are traversing this list from left to right direction, and whenever you are visiting a single node you are adding it to the prefix sum, its value to the prefix sum. So when you will be visiting this node, prefix sum values will be 2, and then prefix sum previous value was 2, and current node that you are visiting is 2 as of now, so it will be 4. So then you will adding this one also to the previous prefix sum value, and then it will be 2, and then you will be adding 1, so it will become 3, then you will be adding again -1, so it will become 2, and then again -1, so it will become 1. Okay, so these are different prefix sum values at different instances when you are visiting different nodes in the given linked list from left to right direction. Okay, so this is what prefix sum is. Okay, prefix sum is nothing but running sum. Okay, if you observe carefully, whenever you are seeing that a certain segment of linked list is adding up to 0, then before that segment whatever was the value of prefix sum is same and as the value of prefix sum after that segment. Okay, so what I mean by this is, or at the end of this segment you can say, so you can see that this 2 is again repeated, prefix sum value 2 is again repeated, because you know why it is being repeated. here the value was 2, and this whole thing will add up to what, 0. So 2 plus 0 will be 2 only. So that's why we are getting 2 here. So that's why this prefix sum value is being repetition here. So this particular observation, that whenever the value of a segment is adding up to 0, and the repetition of prefix sum value will be there, so this particular observation will pave the way to build up the solution. Okay, so, you can observe a similar effect here also. Here you can see that this particular segment will be adding up to 0, and this particular value of prefix sum is being again repeated. Okay, so these values are again repeated. Let me change color here. So as you can see, this value is repeated again. Okay, so there is a repetition again. So whenever this kind of repetition happens, what you will do, you will get the hold of the value of prefix sum just before the segment. Okay, so what was the value of prefix sum just before this segment? It was this. Okay, so you will get hold of that node at which this particular value of prefix sum was there. Okay, so it was indeed this node. Okay, so what you will do, you will change the next pointer of this particular node. Let's call this previous anchor. Okay, and you will change the value of next of this particular node. I mean, you will be cutting this or deleting this link and adding it to and pointing it to this particular node at the end of the segment. Okay, so once you do this, this portion will be automatically deleted. Okay, this portion will be no more, because when you will be visiting this linked list from head to tail, you will not visit this portion, because next of 2 is now pointing to 1 instead of this particular node. Okay, so this is the whole logic here. And to get hold of this particular node just before the section, you will use hashing. Okay, so you will use hashing for each value of prefix sum. You will keep updating what is the node at which this value of prefix sum was there. Okay, so there will be a map will be containing value of prefix sum. So it will be integer data type, and then against that key, you can consider it as a key. There will be a value which will be the reference of the node at which that particular prefix sum value was there. Okay, prefix sum value, node's reference. Okay, so this is the whole logic that we will be using to solve this particular problem. And there are certain edge cases that will be needed to taken care of. Other than that, this is the whole crux of the problem. Okay, and there might be certain cases when we have to take care of certain things. So for example, you see that this particular portion is adding up to 0. Okay, but if let's say you decided to put every value of prefix sum that was there in this particular portion while you are traversing your linked list from left to right, then after deletion of this particular segment, you will still be having these values in your map. So you should handle this case that you should be deleting these values. Otherwise, when you will be seeing this 6 again, you will see that your map is having you have seen this particular prefix sum value before. Okay, so what I mean by this particular thing, I will be explaining in the implementation part. So now without further delay, let's move towards the implementation part. Okay, so let's zoom out a little bit so that a larger portion of code is visible to us. I think now it should be fine. Yeah, so first of all, this will be your running sum. Okay, you will be initializing it to 0, running sum, or say prefix sum. Then this one is the map that will be used to get hold of node previous to the 0 segment that is summing up to 0. This map will be used to get hold of the node just before the segment that is adding up to 0. Okay, so the whole logic, I will again say, is that somehow, if let's say this is the segment that is adding up to 0, you have to somehow get hold of this node and change its next pointer to the next node of the segment. Okay, so these two nodes, when joined together, will anyways remove this particular segment from the linked list. So this is the whole logic. So this map is playing a crucial role here. So then we will be having a dummy head. What this dummy head will do, this dummy head will be in front of the head. Okay, so you can call this dummy head. Okay, and it will be pointing to the head. Okay, and initially, if let's say we have to put 0 sum also in the map, because you know, when we are starting, if let's say there is a value 0, then you have to, this particular logic only works when you have seen this when you are seeing this repetition in the previous sum values. Okay, so this repetition should be there. So what repetition? This repetition I am talking about. As you can see, this is the repetition. So for this approach to work, there should be a repetition. So if let's say there are no other values summing up to 0, so you should introduce a 0 value by your own, and you will make the node at which that this 0 value will occur to dummy head. So that's the whole logic of having this dummy head. Okay, so then you will be just doing a linear traversal of this linked list. Okay, so this is just a linear traverse of linked list, and you will be forming the different values of prefix sum at different nodes. Okay, so adding the current node's value to prefix sum. Okay, then you will check whether you have seen this particular value previously, or prefix sum values previously or not. So what we are doing here is essentially that whenever we are seeing a value of prefix sum that is already seen by us, so we will come to know that there is a repetition, and whenever there is a repetition, that is for sure that we are having a segment which is adding up to 0. Okay, so this will indicate that there is a segment that is adding up to 0. Okay, so you know, and if there is a segment that is adding up to 0, what about the values of the prefix sum that you have already added for that segment? So you have to remove those prefix sum values, because you know this segment will no longer be there, so you cannot have these values in your map. So in order to remove them, this particular logic is implemented. Okay, so what you will be doing is, let me change color here. So you will be having a pointer, let's call this previous anchor, and this is the current node that you will be at when you will see the repetition in prefix sum value. So this was the prefix sum value, which was 1, and it was seen previously, so that's why you will stop here, and till your previous anchor's value reaches to your current node, you will keep adding the prefix sum. So this was the prefix sum 1, so you will keep adding the values of these node. So it will 1 plus 3 will be 4, then 1 plus 4 plus 2 will be 6, and then 3, and then comes the 1. So these values will be deleted. Okay, so that is what we are doing here in this whole logic. Okay, now once we are done with it, we have to just, you know, make this next of this particular node to this node. So somehow getting hold of the node just previous to the segment and making it to point the node just next to the segment, so in order to delete that segment. Okay, so this is we getting hold of node previous to the segment, that is adding up to 0, and making it to point to the node next to the segment. Okay, so this is what we are doing here, and then we will simply, if so we will not again push the prefix some 0 values. So if let's say at a certain point prefix sum value is 0, so we will not be pushing it again and again. Instead of that, if that is not the case, then we will update the prefix sum value with the corresponding nodes value. Okay, so we are just saying that okay, this particular 6 value occurred at this particular node. Okay, so this is prefix sum value, and it occurred at which node? So address of this node, there will be certain address of this node. Okay, so this is just a reference of this node. Okay, so this is what we are doing here, and then we will simply return dummy head dot next. Why dummy head dot next? Because we are making dummy head to point to the head. Okay, so that is how we will be solving this particular problem. And if you ask what will be the space and time complexities here, you can very well observe that as far as time complexity is concerned, we are doing a linear traversal of this list, so time complexity will be order of n, where n is the number of nodes. Okay, and if you talk about what will be the space complexity, since you are storing different values of prefix sum at different instances, so it will also be order of n because of use of hash map, or the map you can say that we are using to get hold of those nodes. Okay, so these will be the complexities. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.